Okay. In this short video, I'm demonstrating how to assemble the AHP Universal Tensile Tester, Tensile and Compression Tester. Standard delivery of the machine is what you see here. When you unpack the instrument, the machine, you will see a hand key that is for manual up and down of the machine. It is with a magnet attached to the body of the tester, and we have a manual up and down connection here. Another cable is for data communication. It's a 3-pin connector, and this is RS485 converter to USB. It will be connected to here, and on the right side of the machine you see the data connection. The other side will go to the USB connector, USB connection of the computer. We noted that connect the USB cable of the machine to the USB 3 port of the computer. Normally it is indicated with blue color in computer standard connectors. The other cable is for load cell. That is for force measurement. The cable needs to be connected to the load cell port. And you have a power cable here. It is 230 volts. 50 hertz, single phase power connection, and you see here on/off key. That's all. It is standard parts of AHP Universal Tensile Tester, and it will be coming to you with a wedge grip, standard wedge grip. That is for plastic parts, tensile testing of plastic parts with the connection pin, and it is easily mounted like this. You can turn it. First of all, you need to adjust the limit switches. You see here in the bottom side of this plate, base plate, we have a limit switch, and whenever the moving grip of we need to move the moving grip downside, and whenever you change the grips, you need to adjust the limit switches at first. You see here, before the two grips touches each other, this should push the switch downside to stop the moving. And now it's not going down anymore, it goes up. Yeah. You can adjust it. You can adjust it using the Allen key. You see here, and adjust whenever you want. and you need to do the same for the upper side limit switch. And that's all. Machine is ready to use. Next step, I will show you how to use the software of the Universal Tensile Tester.
That's it.
Okay, run the software as administrator. Yeah, at first in the first tab you need to set the sample parameters. In the upper side of the page you see the general parameters of the sample, date, time, these two information coming from the computer, date and time. The file number is automatically adjusted. Whenever you start and stop the software, the file number will be added and will be increased one number whenever you start and stop. Test operator and description of the sample, and report file names that will be automatically generated. And for the cross section of the sample you have three options: rectangular, circular, and for some other products like pipe and cable you have donut shape here. You need to define the diameter and the thickness. And for this case, for this sample, I'm going to use a tensile sample. Had been cut with a cutting press. For example, in this case, I need to use this cross section, that is a rectangular shape. You need to define the thickness, 4.3, and the width. This is a standard sample, and the width is 10. The width of the gauge length is 10 millimeter, and that's all. The cross section area will be calculated automatically here. Also you have another parameter here, that is L0. L0 is the gauge length, is defined in the standard related to the sample we are going to test. ISO, for example, about the plastic pipes, it is ISO 6259 part 1 and 3 for polyethylene pipes. And in this standard we have type 1 and type 2. For type 1, that is the sample in my hand, and the gauge length of the sample is 50 millimeter. You need to adjust the L0 here. We need this the L0 for calculation of the elongation at brick. That will be demonstrated in percent. That's all. After adjusting the sample parameters, we can start test. In the other tabs you see here, you will see the graph of force distance, force time, stress strain, and some other tests that can be done with this universal tensile tester. Coefficient of friction, ring stiffness tester for pipes, pull-out tester for compression fittings, and you will have calibration tab here. I will show you how to calibrate the machine in case of displacement, in case of force, and about the extensometer calibration. We have report setting page. The standard report of the machine is in Excel, Microsoft Excel, and the Excel parameters, Excel page parameters will be adjusted here, will be set here in report setting. I will show you later, and in setting page. First of all, you need to come to setting page, In setting page, you need to define which test you want to do. First one is force cut, the other one is displacement cut, and constant force. There are three options for testing with universal tensile tester. It is force cut means that whenever the force level reaches to a specified value that is here, that has been set here, the machine will be stop moving, stop working. The other function is displacement cut. The machine will be stopped based on the displacement you define here. And the other test procedure is constant force. That is, in some cases, you need to have constant force application using the tensile tester with a specified level of tolerances for the force level. The other parameter here is displacement base. We see displacement here. Now it is based on the screw, ball screw. And the other function is using extensometer. In this tester we don't have extensometer. You can add extensometer here. It has connection, it has hardware, electronic hardware, and the only thing you need is the optional accessory for the tensile tester, that is extensometer. You can easily connect the two encoder signals of the long travel extensometer to those connectors. The other keys here is reverse force, reverse displacement. Whenever you want to show a negative force as a positive force, you can use reverse force, and the same about the displacement. And another parameter here is drop down. Drop down is defined for the software for stop of the machine in breakage of the sample. Whenever the sample will be break, it will be stopped automatically based on this force level. I will show you how to set this value. Okay, after all these setting, sample parameters and settings page, now I'm going to use force cut, and the displacement measurement is based on a screw, ball screw. We don't have extensometer here, and we want to start the test. As a tensile tester, whenever you are doing the compression test, you need to set it to down, and now I'm going to use tensile testing, and to do tensile testing, and I need to set the motor direction to up. Adjusting the speed of travel. Speed of travel is defined in the product standard, and the standard method for the testing of the product you are going to do the test. That's all. You can mount the sample and start the test. Now I'm going to do tensile testing in a plastic piece that had been made using a cutting press from a plastic pipe, polyethylene pipe. That is a type 1 based on the standard ISO 6259. You have manual up and down key here. First assemble the bottom side. Yeah. Now you can assemble the upper side. Yeah. After all these preliminary setting, we can start test. You need to click on zero force, click on zero distance. Yeah, that's all. And now we can start. Go to the page force distance here and start the test. Now you see the force is minus and distance is also minus, but we want positive. We can go to setting and reverse displacement will show it as positive, and reverse force will show the force as positive value. Then I'm going to start the test again. Okay. Now for the distance, you can use auto scale and auto scale force, or maybe you want to adjust it manually. You see here when the sample prints, the software will be stopped automatically. And here you see in this graph, whenever for example in this case the drop down is 150 Newton, Here you see when the graph passes the line, the level of 150 Newton, and then the sample breaks and the graph is going down below the 150 Newton, the software will be stopped automatically. And the yield force here, you see the yield point. You can use as many as cursors that you want on your graph, and you can change the parameters of the cursors. For example, color. Here you see the cursor color. Now I'm going to see the maximum point, the yield point here. The force level is 851, and you see the yield stress. And you also can add other cursors, single plot cursors, and define the cursor parameters, cursor attributes, line width, and other parameters of the cursor here. For example, green. Yeah, you can use as many as these cursors on your graph. You can save the graph as a simplified image. You can also report the graph in Excel. Click on the report. And the report will come up in the Excel file. All these parameters can be set in the report setting page on the software here. The title, graph position is the position of this tensile, the force distance graph. Graph position is the starting point of the top left corner of the graph. And also you can adjust the size. Starting point is the row 15 and the column 0 here. Also you can adjust the height and width of the graph, access font of the page, and the other parameters of the Excel can be set here. Other radio button you see here is stop report. Whenever you stop each test, the software will automatically save the report as Excel file, and the numbered automatically. I mean, here you see the file number. Whenever I click on, let me show you here, report setting. Whenever I turn this radio button on, finish one test and start again, it will automatically increase the file number, and the files will be automatically saved in this place. Let me show you. Report setting. The report files folder is here. The tensile test files. Yeah, you need to make the folder. Tensile test files is here. Right. Tensile test files. Yeah. Now you can save the report, but the software will automatically save the results test Excel files in this folder.